Okay, so 3 o'clock Central European time on the dot, ready to begin. Hello, everybody, and welcome back to those that have been joining us before, and a warm welcome to first-time attendees to this training series dedicated to turning biodiversity observations into insights. We will be spending the next hour and a half together discussing about very, very interesting topics, such as one of the main challenges that we are facing nowadays in biodiversity conservation, namely biological invasions. And today, our speaker, our trainer of the day is Tsungai, and I'm really happy that he was able to join us and share a little bit of his expertise. He's one of the leading experts in the field of biological invasions. And as usual, if you do have questions for us, please use the option in Zoom of Q&As to address your questions, and we will try our best to answer them all. In case you are joining us for the first time, please allow me to just introduce the b-cubed project, which is a project that is funded by the European Union's Horizon Research and Innovation Program and is aimed at improving the integration of data on biodiversity from different sources, such as that this data is more easily accessed and more rapidly accessed and is more reliable, and we are using repeatable workflows to do these things. More information about the aims of the project, the outputs of the project, you can find on the website b-cubed.eu, a project that is coordinated by Quentin Groom from Meissen Botanic Garden in Belgium. He is leading a big team of amazing people that are interested in the subject and are based throughout Europe, across Europe, but also a little bit beyond the European borders. So, just a quick recap. Again, in case it is your first time joining us, we did have 2 previous sessions within our training series, sessions that were dedicated to discussing, learning more, sharing experiences about aggregating data and using species occurrence cubes in different contexts. And we learned about that from Andrew and Lina, and last week we heard from Martin and Sandra. If you did not attend those sessions but are interested in the subjects, you can find more information on the b-cubed.eu website under the section News. Today, as previously mentioned, we will continue our discussion of using such occurrence cubes in the context of biological invasions, but using as a case study South Africa and the indicators that they use to produce the report on national status of the biological invasions. Just a quick shout out to what's happening in the following weeks. So please make sure you do join us for the next Fridays as well, and you share the news with your friends and colleagues that might be interested in the topics. There's still time to register and receive updates on the work that we are doing in b-cubed. So, coming back to today's session, as mentioned, it is my pleasure to introduce Tsungai Zengeya to you. He's a principal scientist at the South African National Biodiversity Institute, and he's also a core team member of the Center for Invasion Biology of the University of Pretoria. He is leading the team that is producing the South African National Status Report on Biological Invasions. So he has a lot of expertise in the field, and his research is focused on understanding the factors that influence the distribution and impact of alien species, and how these insights can be used to better inform a policy and the management of biological invasions. Speaking from my own point of view, coming from Romania, I do believe that there's a lot we can learn from South Africa and from the way that they are dealing with the biological invasions. I think we are still lagging a little bit behind on this subject. So I'm really happy to have Tsungai here talking to us about this. Just before I hand over to him, I would like to invite you to answer just a quick poll, 3 short questions that will just help us get an idea about the audience and the participants that are interested in these webinars. And the questions relate to the countries that you're based in, the stage of your careers that you're at, and also the main sector in which you're currently performing your activities. So just thank you for taking a couple of minutes to answer these questions. I think it will be really useful for us just now and for the future sessions and for the continuation of the project. I see that there are answers coming in, so thank you. Just quick questions, quick answers, but very informative for us. Because, okay, I think this will be useful for our speaker also, just to know that we do have a lot of participants, about 30% of the people that answer the poll that are students, so early stage in their careers, either PhD students, master students, we even have undergraduate students. And there's also a couple of postdoctoral researchers and people that are more advanced in their careers as well, which is, again, a nice distribution. So it's perfect. And in terms of the sector that people are activating in, not surprisingly, our main audience consists of people working in academia and research institutes, but also we have some coverage participants that are active in the governmental public administrations, NGOs, even private sector and consultancy. So that is really nice. Maybe just wait a little bit longer for some answers to come in. Please, to answer the poll. Okay. 17. Okay. Maybe we can share the results so participants can also see what the poll looks like before I hand over to Tsungai to introduce us in the subject of reporting on biological invasions and the status of this phenomenon and management in South Africa. Okay, so over to you, Tsungai.
Good afternoon, everyone. Thanks, Christina, once again for the kind introduction. My name is Tsungai Zengeya, and I'm based in Cape Town, South Africa. I work for the South African National Biodiversity Institute, and I coordinate a team which compiles a report which assesses the status of biological invasions and their management in South Africa. And I would like to acknowledge some of those colleagues who are listed on the screen, Katie Faulkner, John Wilson, and Promise Mtileni. Today I'll be talking about indicators we use to assess the status of biological invasions and their management in South Africa. I'm going to go a bit into the background on the reporting, the indicators that are used, some of the issues that have come up, and how the reporting process is linked to other indicators and other projects. So just to give a big background, why are biological invasions a problem? Biological invasions are a major threat to South Africa's water security. They exacerbate fires, they threaten sustainable agriculture, and they have an ongoing major negative impact on South Africa's unique and globally important biodiversity. This phenomena is not unique to South Africa, and biological invasions have been the subject of the recent global developments. For example, the Montreal Global Biodiversity Framework has set an international target to address biological invasions by 2030. Biological invasions have also been the focus of the recent Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Service, commonly known as IBES. We had a thematic assessment report on invasive alien species. This assessment highlighted that invasive species occur across the globe, that invasive species are a global threat. Impacts have been reported from all regions and realms, and in some cases, invasive species cause dramatic, irreversible changes to nature across all regions of the Earth. For example, 60% of global extinctions have been caused or attributed to biological invasions. Biological invasions are also a distinct phenomenon with particular impacts affecting different sectors of the society. For example, you can have invasive trees like prosopis, which are known to reduce water availability, grazing land, and impact human health directly, particularly through the production of allergenic pollen. You also have water icing, which can block pathways, waterways, and can also create breeding grounds for disease and pathogens. You also have invasive predatory fish, which can impact the livelihood of local fishermen. The IBES assessment did highlight that integrated governments can dramatically improve the management of biological invasions. For example, one of the strategic actions is to develop and adopt effective and achievable national strategies. In South Africa, the white paper on the conservation and sustainable use of South Africa's biodiversity outlines the government's commitment to the issue. We also have a national strategy on biological invasions, which is in preparation. And this, together with the status report on biological invasions, provide a mechanism to integrate actions and to help report on progress. Why do we compile this report? In part, it's meant the Institute is mandated by national regulations to monitor and report on the status of biological invasions at a national level every 3 years since 2014. This report must contain a summary and assessment of the status of listed invasive species and the effectiveness of these regulations and control measures. The report aims to strengthen the links between basic research, policy, and management. For example, in an ideal world, research is conducted that flows into policy. Policies are then implemented through specific interventions. The efficacy of these interventions are then monitored and evaluated, and then these findings are then used to improve management and direct research. But in a real world, things are more complicated. Different institutions do different things. Different individuals do different, and also different individuals do different things. They might use different terms and have different goals. In many cases, there simply aren't any linkages there at all. This is where the report comes in. It facilitates the link between foundational research and the monitoring and evaluation of interventions in a manner that can assist managers and policymakers. So when we started compiling this report back in 2016, we didn't have an indicator framework on which to base our evaluation on. So we had to develop that from first principles, and we managed to publish that framework in the Journal of Applied Ecology. The framework is based in part on the essential biodiversity variables, where essential variables for invasion monitoring fit within the broader framework of EBVs. EBVs are the measurements required for the study, reporting, and management of biological change. And then EBV framework underpins the development of a global system of harmonized observations on biodiversity change. Similarly, the essential variables for invasions monitoring underpin the development of a global system that could be used to assess and track status of biological invasions. They essentially have three essential variables. These are alien species occurrence, alien species status, and alien species impact. I'll touch on each of these in the next slide. So for alien species occurrence, these data on the presence or absence of an alien species at a specific location will help inform risk assessment, identify priority areas, and track special trends. For example, at a basic level, a country could start initially by creating a list of alien species that are known to occur in that country. And as these systems mature and develop, they could then prioritize the presence of those species at priority sites. This could be protected areas or areas of high biodiversity. And then this could be extended further by having more information on the extent and the area occupied within those areas. And by establishing long-term monitoring systems, you could then track the occurrence of those species across those long-term monitoring sites. The framework is also underpinned by the species alien status, and we mainly use or adopts the framework, develop the unified framework, which essentially describes the biological invasion, the process of biological invasions, in that a species has to be introduced, has to be transported from its native range, it has to be introduced into areas outside that native range, and once there, it has to establish and spread. And for it to go through all these 4 stages, it has to overcome certain barriers, which can be geographical, or it has to transition from cultivation into natural ecosystems. The last one is the framework also leans on the various frameworks that have been developed to assess the impact of alien species. These are essentially the ICAT framework, which assesses or classifies environmental impacts across 12 different mechanisms and assigns a magnitude score, which vary from minimum impact or minimum concern up to species that cause massive impacts. Similarly, there is a similar framework which assesses socioeconomic impacts. There is the CCAT. It's used to assess the impact of alien species on human well-being using 4 impact categories, mainly safety, material or immaterial assets, impacts on health, and impacts on social, spiritual, or cultural values. And these magnitudes of these impacts are also then assessed across the 5 levels which are similar to the ICAT assessment. So when you look at the framework, in summary, it's based on, it's structured across 4 themes. The first theme is how alien species are introduced and how they are moved around the country, which we call pathways. The second theme is on the status and impacts of alien species. The third one is on sites, how sites are embedded and how they're impacted. And the fourth one is what's being done to address the problem, which we call interventions. We originally split these across 3 themes: inputs, outputs, and outcomes. The initial indicator framework was published in 2018, and I think the ongoing work has been trying to revise and update it. And some of the key revisions that we have done is trying to link the indicators to different metrics, especially the one which specifies driver, pressure, state, impact, and responses, and also to frameworks which use causal inference. For example, theory of change framework, which specifies inputs, processes, outputs, and outcomes, especially as they pertain to invasions. And these outcomes can be invasion specific, or they can be broader outcomes. For example, you're looking at release of species, or you look at the fire danger index, for example. The second major revision which we have done is the indicators are now included in analysis to the degree which each of the indicators adheres to desirable properties of indicators that are used to monitor biological invariance. For example, one of the properties is, has that indicator been applied in a real-world scenario, and do the assumptions hold, or what are the limitations? Is the indicator spatially explicit? Is it scalable? Is there some analysis of uncertainty with the analysis of the variables? Is it specific to alien species, and is it reproducible? Another aspect of the indicator is that it follows a hierarchical matrix, in that at a basic level, you use the assessment varies from a basic level to complex. So, for example, if the slide on the screen, the indicator assesses the number and status of alien species. At a basic level, you just want to know how many invasive species are in a given area. It's easier to know the number of invasive species because invasive species, by their definition, are species that are widespread and they're usually conspicuous components of an environment. But when you go into a more complex analysis, you're now looking at including species which might be present but not yet established. So they might be there in low numbers and difficult to detect. And at a higher level, you even go to assigning the number of species according to the 12 categories of the unified framework based on degree of establishment. I'll touch on this example in a few slides from now, and probably just illustrate how we apply it in practice. The indicators, each indicator also has an analysis of uncertainty, where we assign confidence level to the information we have. So, for example, if you're looking at the rate of introduction for alien species using a particular pathway, if you have high confidence with the information at hand, it's mainly as a result of that, there is direct evidence of the introduction pathway. A medium level of confidence is when a species, for example, appeared when and where a single pathway was in operation, and there's no other explanation on why it could have, on how it could have got there. At a low level, for example, the pathway of introduction is inferred from other sources or from species traits. And then we also follow the recommendations of the guidelines of the Biodiversity Indicator Partnership, where for each indicator we developed an indicator fact sheet. The fact sheet summarizes why the indicator was developed, what it aims to assess, what metrics it is measured in, how to calculate it, how to calculate level of confidence, and how to interpret the results, how they can be applied. So the fact sheets which we have for the indicators are presented today. They are available on Zenodo. You can use the link or the QR code if you want to go in detail how the indicators were developed. In the next coming slides, I'll just pull some examples and just illustrate some of these indicators on how we have applied them. So for pathways, the indicators for pathways of introduction and dispersal are mainly highlighting the processes that lead to the introduction of alien species into the country and their spread within the country. So we have divided them into pathway-specific drivers and invasion-specific outcomes. For pathway-specific drivers, there are mainly two indicators. These are mainly look at pathway prominence. The first one looks at considers the opportunities for introduction into the country, but it does not take into account how many introductions these opportunities result in. This is done through another indicator. The second indicator on pathway prominence, it focuses on within country. But once a species has arrived in the country, what are the opportunities for that species to spread within the country? When you're looking at invasion-specific outcomes for pathways, we have one high-level indicator, which looks at the rate of unregulated introductions of new species. It basically provides an indication of the potential future biological invasions. It's also a metric by which the effectiveness of biosecurity interventions could be measured against. The complementary indicators for that high-level indicator are introduction rates and within-country dispersal rates. Introduction rates considers the introduction of new alien species to a country from another region through each introduction pathway. And for dispersal rates, it considers how alien species disperse within a country through each pathway. Just to illustrate one of these indicators, I'll use introduction rates. As I have mentioned, it considers the introduction of new alien species to a country from another region through each pathway. It can be used to answer three questions. How many species have been introduced through each pathway? Is the number of species introduced through each pathway changed over time? And how is the number of individuals of a specific species introduced through the pathway varied over time and space? It considers both propagal pressure and colonization pressure. So the units in which it is expressed, at a basic level, you're just telling the total number of alien species introduced through each pathway. And here we use the CBD pathway framework. And then at a medium level, you categorizing, you have 5 categories that demonstrate change over a recent time period. This could be, you can specify to any period you're interested in. These categories vary from are not known to categorizing an increase or a decrease or a minimal change. And at a more complex level, you're looking at the number of individuals of each species introduced through the pathways and place and date of introduction. So just to illustrate how when we've applied this indicator, what kind of information we get. So in South Africa, the reports we have compiled so far have highlighted that there are a wide range of opportunities for introductions, and new alien species continue to arrive each year through several pathways. For most pathways, there have been relatively little change, but with most introductions being plants introduced for horticulture and ornamental trade, plants introduced for agriculture, and you also have contaminants or parasites of animals or plants in their products also making their contribution. And then you also have stowaways on ships, and this includes terrestrial species on ships as well as aquatic species in ballast water or on the house. What are some of the limitations or issues which have come up when we're using the indicators? We have noted that there can be difficulties associated with categorizing species into each of the CBD pathway subcategories, and this could lead to some inaccuracies. And the second one was if the pathway and date of introduction information are not available for many of the species, it's quite difficult to monitor trends, as you might get false trends of either decrease or increase. Trends may be influenced by the frequency or intensity of surveys of alien species. And the last one, it does not consider whether, in some cases, the introductions are desirable and whether the introductions are desirable or not. When you're looking at species, for species, all the indicators are classified as invasion-specific outcomes. So the main indicator for species is the number of invasive species that might have major impacts. So this indicator considers alien species that have been reported to have major or massive impacts in a country when they were analyzed using the ICAT or CCAT frameworks. And these species are noted as being of significant concern, and as they inform what needs to be done, for example, species-specific control efforts that are currently needed to reduce the impacts of those invasions. So an implication of an increase in the number of species with major impacts is that it indicates an increase in the consequences and the management complexity. As the number of, for example, as the number of species grows, so likely will lead that the range of impacts will also increase. The other complementary indicators for species are the number and status of alien species. This indicator provides the basis for constructing a list of alien species in the country. You have the second one on the extent of alien species. It provides an indication of how widespread alien species are and provides information that can be used for metrics of how invaded sites, how sites are invaded and where impacts might be okay. Abundance of alien species provides an indication of how many individuals there are of a particular species. It can be used as part of a prioritization efforts for species-specific control programs. Impact of alien species, it identifies which alien species are causing the largest negative impacts. It helps identify which types of impacts are most common. It also, if the current level of impact level is less than, so it helps identify the impact mechanisms and how alien species might be impacting other native species or native biodiversity. And when you look at the use and interpretation, just to illustrate with the number and status of alien species, as I indicated, it's used as the basis for constructing a list of alien species in the country. Such information is important for biosecurity, to be able to target species which are not yet present, and also to identify threats based on what is already in the country. If the status is known, this can be used to estimate the establishment part of the invasion date. That is how many alien species are likely to establish in the future. It also gives an indication of the effectiveness of species-focused control measures. The units in which it's expressed, this is the earlier example I gave, that at a basic level, you're looking at the number of invasive species, but at a more complex level, you're now looking at the number of alien species in various categories of introduction status and also degree of establishment. For example, when we have assessed over 6,000 species which are known to be present in South Africa, and of these, there are about 4,000 are known to be present, and we have also categorized the status of these species, and you can see that a large majority of these species are either in cultivation or in captivity, and also that there's quite a large proportion of them which have become invasive. What's not shown here is that a large proportion of these are plants, and this highlights that South Africa is a hotspot for plant invaders. For us to be able to create such a list, we have to put processes in place to capture and record what's present in the country and to verify if there is evidence that actually ascertains that species is present in the country. So this process to create and curate the list has evolved over time. Key developments have included improvements on how data are presented, how we track changes, and the degree to which information was consistent with international best practices. The development of documented and repeatable workflows has ensured there is clarity on why a species was included on our list, and this helps facilitate reviews and also updates for future reports. And as part of this process, we are also part of the organizing committee that initiated a special issue on developing lists of alien taxa in the Global South. It was spread across 3 journals. First journal was Neobiota for broad high-level papers, and for papers specific to the African continent, those were published in African Biodiversity and Conservation. And for papers that were specific to countries in South America, that was published in the journal by Zonis. And the papers highlighted workflows and protocols and processes and experiences from people who have been involved in developing lists for alien species in their country. And several papers have already been published. I think we're in the process of finalizing the special issue, and most of the papers are already out. You can, if you want, you can go have a look at. There is a paper specific to the process in South Africa, and the second QR code will give you a link to all the papers that have been published in the special issue. And the other QR codes are linked to various documents of highlighting processes we have put in place in South Africa to create such a list. And I also just acknowledge the editors of the special issues and the people in South Africa involved in helping compile such a list. So what are the limits and some of the in trying to apply the indicator? This indicator, we have seen or we have noted that the list of alien species in a country is never complete or perfect. These lists are dynamic and they need constant updating as new alien species are discovered, populations die out or are expected, and as new information becomes available. Therefore, this list, like all lists of alien taxa, represents a snapshot of the situation. The presence of many alien taxa still needs to be confirmed and documented, and many data sources still need to be added or incorporated into our list. And like many alien taxa, so many alien taxa have not or as yet been recorded, and as they get discovered, they also need to be added to the list. And there are also other various limitations that, for example, the list assumes an equivalence between species. One alien tree species is same as a mite species. It relies on species being well-defined concepts, but we have noticed that when you try to manage things be above or below a species concept, there are some practical limitations. It also does not encapsulate invasions at a lower level than the whole organism. And there has been some inconsistencies in the use of terminology. For example, the definition of what is an invasive species. There are various definitions out there, and it's also reflected on how policies might be applied. For example, the regulations in South Africa use a different definition than what is used in our report. And there has to be some engagement on how we could rationalize the difference between those definitions. So when you look at sites, there's one high-level indicator and three complementary indicators. So the high-level indicator looks at the extent of areas that serve as major impact. These definitions are intended to correspond to those of the ICAT schemes. And this high-level indicator gives an indication of the overall extent of impacts of biological invasions. Invasion areas are expected to deliver fewer or diminished ecosystem services and will support lower levels of biodiversity if they have major impacts. So the complementary indicators, the first one is on alien species richness. It gives the number of alien species that are known to occur at a particular site. Higher numbers often indicate a higher number of issues to be addressed. Higher numbers of invasive species indicate the number of issues to be addressed, while higher numbers of alien species indicate a higher risk of invasions, as a proportion of these species can be expected to become invasive over time. The indicator can be used at a range of scales to track invasion depth. The second indicator is on relative invasive abundance. It measures the degree to which a site is invaded by considering the combined abundance of all invasive populations present relative to the abundance of indigenous and invasive organisms. It is a useful indicator of the degree of stress of an ecosystem, and it can be used also at a range of spatial scales. The last complementary indicator is impacts on invasion. This assesses the impact on the delivery of selected ecosystem services on biodiversity invasions at a site. It normally, when it's applied, it should focus on ecosystem services that are imported in the context of the site that is concerned. For example, in South Africa, for us, we look at the impact on water resources. We also look at the impact on livestock production in rangelands or biodiversity in protected areas. This indicator provides an information that is useful to prioritize sites for management interventions. At a more advanced level, the value of impacts could be expressed in monetary terms and so used to assess the benefits of control. Sorry, the cost and benefits of control. Just to illustrate one of these indicators, I've used alien species richness. As I said, it's an indicator of the number of alien species at a particular site. High number of invasive species indicate issues to be addressed, while high numbers of alien species indicate a higher risk of invasions. It can be used to track invasion debt, and the units in which it is expressed. At a basic level, it can be used at a large scale. For example, in the figure shown here, you could be looking at the number of species at a country level, or you could be looking at number of species in each of the provinces. And at an intermediate level, it can be a finer scale. So in this case, yeah, it could be the provinces. But at a high level, you could look at even a finer scale. In this case, we use quarter degree grid cells. So you could look at the number of species that are known to occur in each quarter degree grid cell. And also, you also then have to assign their status as per the unified framework. So to give an example, from some of the results we got in the report, we have noted that invasions are known or distributed across the country, including even in protected areas. Most alien species are found along the coast and around major urban areas. For example, in the figures shown, the alien species richness for birds and plants appear to be highest around major urban areas. This is likely due to greater survey efforts in those areas, and because some of these species are commensal with humans, and most of the species were first introduced in those urban areas. When you look at some of the limitations when you apply the indicators, we have noted that citizen science continue to provide information on the extent of some species, with notable increase in observations around urban areas. However, there are no national long-term structured monitoring projects to track invasions across South Africa. There are also significant gaps in the knowledge of the presence and distribution of taxa that are not currently covered by specific atlasing projects. For example, the number of alien terrestrial plants and vertebrate species is well documented as a result of past atlasing projects, but there is less information on other groups such as vertebrates, soil organisms, or microorganisms. And when you look at what's been done to address the problems, you have a high-level indicator which assesses the level of success in managing invasions. The degree of success is often achieved by control measures often varies from place to place, and this indicator is intended to provide an overall assessment of the effectiveness across all projects. High levels of effectiveness would indicate that control measures are appropriate and that the goals of management are realistic and achievable. In contrast, low levels of effectiveness would indicate inefficiencies in management or unrealistic expectations and goals, or both. It should trigger some form of adaptive management where people will relook at reallocating resources or reevaluating project goals or redefining ways in which things are actually implemented, or the methods used to to implement the projects. And for each of the for pathways, species, and areas, the indicators should provide a list of activities, inputs, and outputs. For example, for activities, you look at things like, is there a regulatory framework in place which is used to enforce control or interventions on biological invasions in a given country. You also look at, is there resources available? It can be money or human resources that put on the ground which are actually there to implement these projects. You also look at planning coverage, which is, are there management plans in place to actually plan on how these interventions are going to be implemented? And for inputs, you're now looking at what has actually been done. For pathways, for example, have there been interceptions at the airports or at the border crossing points? How many species or areas have actually been treated or have had a control project implemented? Effectiveness outputs is basically measuring, is all these actions making any difference? So just to illustrate with pathways, for South Africa, from the report, we have noted that the regulations are not specific in their requirements to have pathway management plans in place. It's implied, but there are some certain plans which have been developed through other forms of legislations, like the Ballast Water Act. So some ports have developed ballast water management plans. We also have several points of entry into the country, and a big development has been that the Border Management Agency was established. Previously, you could have at one border entry, you could have 4 or 5 different government agencies, each policing a different aspect of that border entry. For example, you could have officials from Customs, Department of Agriculture, you have the police, you have the army, and each of them would be looking at a particular thing at that point of entry. What they've done now is that all those activities are now coordinated under one border management authority, so that there's no duplication of effort, and there's also it increases the efficiency to regulating activities around that point of entry. So as you can see on the figure there are several international entry points that are being monitored, and of these, I think 40 out of the 44 pathways are being managed to some extent. And through activities at this points of entry, there have been some interceptions of illegal imports or luggage stowaways have been intercepted. The efficacy of these interventions at the moment is still unknown. It's largely an artifact that there is no systematic monitoring pathway treatment, and their effectiveness is not assessed by the management agencies that implement them. When you look at species-specific interventions, there has been a notable shifts in funding. Most notably, the amount spent on biological control research and implementation over the past 5 years has declined. This decline is mainly due to the termination of funding from government to several institutions that undertake research on biological control. There has been some privately funded initiatives by national and governmental organizations, such as the Nature Conservancy, which have funded water funds in mountain catchment areas around the city of Cape Town. These are mainly looking at controlling invasive plants in those mountain catchment areas. There are some species-specific management plans that have been developed, but these have not been formally adopted. And when you look at inputs, using the example of biocontrol again, you could see that there are over 90 biological control agents that have been established on about 66 alien plants. And of these, 54 alien plants are now under what is termed substantial or complete biological control. And when you look at site interventions, I think the main theme again is the decline in funding, where there's a noticeable decline from the funding levels in, for example, in 2017 to what is currently available to support these interventions. And in previous reports, we highlighted that almost 3 million hectares have been subject to control interventions for trying to get rid of alien plants. And of these, about 8 million have also had follow-up treatments just to make sure that things don't re-sprout and the problem starts all over again. And because of these actions, there have been localized success. But when you look at a national scale, there is continued growth in populations of all other species. And some of the localized success have led to recovery in national vegetation and increase the amount of grasslands that are available for grazing to support livestock production. So just to summarize on these indicators, when you look at the high-level indicators, we then aggregate all those indicators to have these 4 high-level indicators which we use to monitor the status of invasions at a given period. So the ones on the screen now summarize the trends over the past 3 years. That's between 2022 and up to 2025. And you can see for the rate of introduction of unregulated species that we've noted that the rate of introduction has stabilized. It hasn't changed much. It hovers around 4 new taxa introduced a year. And this is similar to previous estimates from other reports. The estimates of the number of invasive species that have major impacts. The major challenge has been that a few taxa have been assessed. But of these few taxa that have been assessed, there are about 19 species that have been shown to cause major or massive impacts. And in addition to these ICAT analysis, there have been other complementary assessments using risk analysis frameworks and also findings from the EBS invasive alien species assessment, which have confirmed that these species cause widespread harm to society. When you look at the extent of area that suffers major impacts, historical studies which were done 2008, I think, have highlighted that biological invasions have major impacts on biodiversity, ecosystem services, and human livelihoods. And the major challenge has been that we have been trying to replicate and update these estimates, but there have been challenges in trying to set up those processes and trying to replicate those studies. But complementary studies or complementary assessments have shown that biological invasions still continue to cause major impacts on those ecosystem services. The level of success in managing biological invasions, we've noted that the interventions are in place to address all facets of managing biological invasions, but the decline in funding is a major worry. Despite the local success, invasions are increasing in extent and when they are assessed at a national scale. So to summarize, the indicator framework, it consists of about 20 indicators. There's 4 high-level indicators. Each of the indicators is structured into a hierarchical metric, and each indicator has some measure of uncertainty, where we assign confidence levels, and we have developed fact sheets for each of these indicators, which could be used to just to highlight why the indicators were developed, how you can apply them, and how you can use the results to infer changes in trends in biological data. So in the next few slides, I'm just going to highlight how all this links to other work which has been done to develop and implement indicators. So the Community Montreal Global Biodiversity Framework has target 6, which is mainly focused on biological convergence. And the headline indicator for that is the rate of invasive alien species establishment. This is similar in some ways to the high-level indicator we have for our report in South Africa on the rate of unregulated introductions of new species. But as noted by other studies, these indicators the data used to calculate the headline indicator for target 6 must take sampling effort into account. Otherwise, misleading patterns will emerge. For our report, we also noted that there are extensive data gaps that exist, and proxies of survey effort have not been routinely captured. We've noted that improved institutional coordination would assist alleviate some of these concerns, but they still need for work and capacity are still required to bridge this gap. When you look at the complementary indicators for the headline indicator for target 6, there are 3 of them. The first one is on the rate of invasive species impact and the rate of impact. This is linked to one of our indicators in our framework on impact of alien species. And there are processes that are being developed to calculate this indicator based on work piloted in South Africa and as part of the b-cubed project. And I think the last training sessions of this series, I think Sabrina and Mukta will probably present on what they're doing on their work around calculating this indicator. And once these are developed, once developed, these processes will be tested and applied in our future reports. The other 2 complementary indicators, the rate of invasive alien species spread, are linked to several indicators of pathways within country pathway prominence and within country dispersal rates, and also to the extent of alien species. While the last one is linked to the indicator on introduction rates. When you look at the complementary indicators, there are 3 again, and I think they're also linked to several indicators on our report on a number of studies of alien species richness, and the impact of invasions. And for the link to the biodiversity building blocks to this project, the b-cubed project, we one of the case studies where we envisage that the data cubes, models, and indicators developed under the b-cubed project will feed into our reporting processes, and it will show the usefulness of the b-cubed project to an end user perspective, which will be us in this case. The projects, we hope that the project will address 3 of the 6 gaps we identified in previous reports. These are on alignment of indicators, mobilization of spatial data, mobilization of impact data. And we also hope that it will assist us in the automation and standardization of the process of our reporting processes and how we report and communicate the findings from them. So just to illustrate some of the linkages between our indicators and some of the projects or products which come out of the b-cubed project, there are several direct links, and several of these projects or several of these products will be implemented in our next report. But there are several ones where there's no direct link, and we have flagged these for possible inclusion in future reports. Just to conclude, just to highlight, if you want more information on the report, you could find it on our website. The link is on the screen. We have also uploaded all the copies of all the documents we have highlighted. They are available on Zenodo, and the paper on the indicator frameworks is also, I think it's available open access on Journal of Applied Ecology. Thank you for your time, and I think that's my last slide.
Thank you, Tsungai, for this very interesting presentation. I would invite now, as I see people were a bit maybe shy to ask questions, if they do have some questions, just to address them now. Maybe we can have a little bit of discussion on this very interesting topic of biological invasions and the way they're managed in South Africa. I think there's a lot for us to learn from you. Perhaps I can already ask something in the meantime. Yes. Because I saw quite a little bit of parallels between my country and the status of biological invasions in my country and what is happening in South Africa, although we are still, as I mentioned, lagging a little bit behind, since we are now just at the stage where we are compiling all the information that we have at national level just to produce the list of alien species in Romania and gather the information. So at least we have a sort of database, like a baseline of the status. What would you suggest, like main recommendations based on your experience moving forward for us, like for like a long-term plan of management of biological invasions? What would you suggest that we focus on? I know that, yeah, considering there's a gap in what we know, there are gaps in knowledge, so the uncertainty is quite high, and of course the funds are limited. Of course.
I think we, as part of the special issue I highlighted, one of the papers we did produce there was the lessons and challenges we experienced while we were trying to compile that national list of alien species. We came up with about 8 recommendations, and they vary from things like take a modular approach, where you could start the process with the data you have at hand, and over the years you can try to build it up and make it more comprehensive. But you shouldn't restrict yourself at the onset to say this project should solve everything at the beginning. Then one of the lessons we highlighted was learn by doing, which is you could do or produce something based on your understanding or resources available, and then you can improve on it with time as your expertise grows, or as we are doing now. We joined the b-cubed project, and from that project, we will learn several things which will hopefully improve our processes. So that learn by doing. Some of the lessons are also, you should have dedicated resources available. So you should have a champion or a point person who manage the process in the long term. And once you make the commitment, also the institutions or the powers that be, they have to understand that they have to provide enough funding and also other resources to essentially, it's a long-term project. Just to be sustainable, they have to provide funding and to sustain it. So the paper is available. Other QR codes which are available if you want. You can. We do go into a bit more details on how we solved each of the challenges we encountered and whether we recommend it to someone else to do it.
Perfect. Thank you so much for your insights. And I see now that there are a couple of questions in the can you actually see them, or do you want me to help with the?
I can see 3. I can go through them.
Yeah. Okay, perfect.
The first one is, Alexander mentioned that you mentioned that there was no compensation for survey effort. Don't occurrence cubes compensate for some of the survey effort? I think yes, they do as part of the b-cubed project. I think several of my colleagues will be presenting on some of the methods which you could use to compensate for survey effort. What we highlighted in our report was that we sourced data from different people, different data sources, and the comprehensiveness of that data, it varies. And so there has been one major challenge on how you could use a protocol which will compensate for survey effort when you have different quality of data which you're pulling from different sources. But the short answer is that I think that there are ways to estimate that, and we will be trying to implement those, especially learning from some of the products from the b-cubed project. The second one is from Steve. What will be the key interventions going forward, and what roles will monitoring play? I think for South Africa, if I can use one example, I think it's one of the few countries which launched a large-scale control program, mainly looking at controlling invasive plants. But it has had challenges because you dedicating a large portion of the fiscal budget to managing a particular project or a particular aspect, a particular problem in society, but the needs to manage biological invasions will compete with other societal needs, like, for example, money going to health or going to construction of key national infrastructure. So you have to demonstrate how managing biological invasions compete with all the other societal needs. So it was modeled around you do control biological invasions, but at the same time you create, for example, opportunities for employment for people to actually be employed in part of those interventions to control invasive plants. So if such projects if funding for such projects is made available and they're sustainable in the long term, I think that's one way to continue the key interventions. The second one, I think there or we have shown that biological control it has been very effective. When you use the cost-benefit ratio, it has one of the highest cost-benefit ratios as compared to any other control methods. And it's one, I think, ideally where funding should have been sustained and it should have been controlled, continued in the long term, because we have shown that it actually it's quite effective. But the challenge, as I indicated earlier, you need to demonstrate that you equipping society to get jobs or to and biological control to some extent doesn't, or it does, but not at the same level as employing hundreds of people to manually clear a plot of land. So those, to my mind, those will be the two key ones which they should keep going forward. And for monitoring, the challenge is you need to know where and how abundant alien species are for you to implement any control projects. And at the moment, one of our challenges is that we don't have that comprehensive data on the distribution and extent of plant, for example, plant invasions in South Africa. We have tried, or there have been projects which have prioritized certain areas, like areas that they call strategic water areas. These are areas where most of the surface runoff water in rivers or underground water is generated. It's usually mountainous areas up in Hazel. So they have targeted controlling alien species in those areas and also trying to map the extent of invasions in those areas. But these projects, I think they're not long-term in that they were funded for a specific period of time, and most of them have ended, and to date, I think there are no plans on how that can be carried forward. We also had a survey or an atlas where people would drive around and they would note the distribution of plants in South Africa. It's call it the Southern African Invasion Plant Atlas. It actually produced quite a comprehensive data set of distribution of plants around South Africa. But again, questions around funding and capacity because the champion of that Atlas project retired and there wasn't anyone to take over, and then also challenges with funding. So those are so monitoring. In short, it helps you or informs you which alien species are there, which species you should focus on, and also whether any control measures you have put in place, whether they've been effective. Then there's another question, Alexander. How did your yet to be published unpublished paper on define naturalization and what were the criteria? I think for this we leaned mainly on the unified framework, and we didn't change that definition from the Blackburn and Tao paper. So I would refer you to that. We didn't change that definition or interpret it differently. Then Paulina, can you share your experience regarding how stakeholders across different sectors have reacted to the findings of these reports? Has coordination become easier, or has there been some problems? We actually identified that as a key, something that was missing from our reports, because we had concentrated on just trying to set up the reporting processes and trying to get at least 2 or 3 reports out of the way. And what we been told by some of the key stakeholders was that we need an assessment on whether these reports are actually useful. So as part of this report, we actually had, we designed a survey where we're trying to gauge the stakeholder, how people, stakeholder perceives the usefulness of the report. And that survey, I think, closed last week, Friday. So we are in the process of trying to analyze the feedback we got. So we hopefully should publish a paper sometime this year on how that, how stakeholders perceive the report. Hopefully it will be positive, but we'll see where the paper comes up. Thanks for sharing, but my question is, how is this invasive species influence ecological restoration? I think for our report, we have mainly looked at the remit of the regulations, which has been looking at summarizing the status of the species that are known to be alien or invasive in the country, and giving an assessment on whether the control measures have been effective. We haven't looked particularly at ecological restoration as part of the indicators per se at the moment, but it's probably something we could flag, and we could it could be included in official reports if we operationalize how to incorporate it into the indicators. Steve, what? I think it's just a comment. There seem to be all familiar challenges to all. I don't know if I answered all the questions sufficiently, or if there's a follow-up question.
No, I think you've answered all of them. Thank you. And I completely agree with the comment that these are familiar challenges to all. And the work you've done in South Africa is certainly informative to many of us. So thanks again for taking the time to introduce us a little bit in the topic, Tsungai. Thank you. I think we are ready to wrap up, unless there are other comments as well. So just to quickly give a shout out to our next session, like next Friday, when we'll get together again with Sandra, and she will talk to us about automating compositional dissimilarity and biodiversity turnover mapping using this DisMapR tool, a framework that she has been working on. So make sure you join us again next Friday at the same time, same place. And just to remind participants that there is additional resources, information that you can use on the b-cubed website. Under the guides and tutorials tab, you can find a lot of the outputs and information on the work that has been developed throughout the project by all these amazing people. So to wrap up, you find us on different social platforms. And of course, you have the website that you can navigate to. There's a newsletter then that you can sign up for. And if you have other questions for us, please do get in touch. You have the contact details of Tsungai, and you can always use info@b-cubed.eu to get in touch with us. Certificates of attendance are available upon request, so just get in touch with us and we'll try to solve any issues or answer any questions or just keep in touch. So thanks again for joining us this Friday. Hopefully we'll see you next Friday as well. Enjoy the rest of the day and of the weekend. So thanks again, everybody. See you next time.